All right, so this is question 20 of the 2023 exam. Um, all right, so this question here talks about two functions f and g, and it's asking for when the largest interval for fog and goff both exist. Now, this table here just quickly identifies the domain and range for both f and g. And I've written down here fog, the condition for fog to exist, and for goff, the condition for goff to exist. So let's do a quick check and see if there are if this exists at the moment. So the range of G is -1 to 1. And is that a subset of the domain of f, in this case, 1 on root 2 to infinity? In this case, no. So let's have a look at the other one. We've got the range of f, which is -infinity to infinity. And we're going to see if that's the subset from domain of G, which is -infinity to 5. Again, no. All right, so what we need to do for this question here is we need to work out where is the restriction. If I look at this point here, the reason why fog is not a subset is because of this part right here. Now, I'm going to focus and translate this in a way. So the range of G is not a subset of the domain of F. So we almost want to make sure that we can manipulate this value here so that it can be within the actual domain. So let's put it in other words. The Y value of G, so G of X is equal to sine X. So this value needs to fit in with the domain of F. So we want to change this G value so that it fits like this. So in fact, I'm just going to equate the two. So why don't I equate the two, and I'll end up getting, I'll write it on this side, -1 on root 2. Now, if we solve this, what will happen is that we need to solve for a range of values, and I won't spend time on this video doing this, but you'll get the answers negative pi on 4, 5 pi on 4, 7 pi on 4, -3 pi on 4. In fact, you should really be expressing this as a general solution because of the following things. This domain here for sine x is from -infinity, so you really should have a whole bunch of answers. But for the sake of this question, we're not going to do that. And we're going to cross out 7 pi on 4 because that actually falls outside of the domain because it's larger than 5. So really, this is the largest value. I don't know if it's square round brackets, but this is the largest value that we want for our domain of for our domain of of G. So let's move on to the next step. Now, if we look at what is stopping Goff from existing, the stopping Goff from existing is this part here and this part here. So let's go back to that same idea where we've got the y values of f. So if I've got f of x is equal to log e x plus 1 over root 2, what is stopping this range of f? So the y values of f, so this part right here needs to be restricted so that it's less than 5. Okay, so it's less than 5. Less than 5. Okay, and if we solve this, let's just rearrange this. So e to the power of 5 minus 1 on root 2 is less than x, is greater than x. You can see at this point we've got another bound that we can work with. So how does this all tie in with our question? Because we're nearly there. So if we look at that bottom bit first, right? Sorry, this should be the other way around. That's the next. What is the domain of G needing to be, oh, sorry, domain of F? The domain of F needs to be restricted so that it's no longer this, but instead it's from negative 1 over root 2 to e to the power of 5 minus 1 over root 2. So the domain of f needs to be restricted to this. Okay, so let's have a look at the domain of, g. What does that need to be restricted by so that we can get a solution here? So domain of g, in fact, we can't, we need to make sure that we consider this. This is essentially this because those are the solutions to this equation. So we've got 5 pi on 4, and it's square brackets, round brackets, sorry. And the lowest value that it can be is, I'm going to check something here. The lowest value that it can be, so sorry, going back to screen here, is really any possible solutions that we've just worked out here. So we can actually, I might be wrong with this one, but we can say that it's negative infinity. And so if it's negative infinity, we really just don't mind with this one because we just want to find out where can they both exist together. Now, I just calculated this before. This is 147-ish, so that's a really high number in the hundreds. And for the upper bound, this is a low number. This is a single-digit number. So the upper bound for them to exist is 5 pi on 4. Okay, can't be more than that because otherwise domain of G doesn't exist there. And the lower bound, obviously this one here, is going to be the restrictor. So we've got 1 on root 2 negative. And you can see that becomes our possible answer in this case.